Okay, are we back? I think we're back. Okay, wow, that's bright. Okay, so protocol. Small formal recipes for stateful interactions. Create. DID com. Areas. Metaframe protocol. DID exchange. Metaframe protocol, single message sent by the sender. Okay. Look for creating a period DID in the Genesis version of its DID doc can be done at any time and does not require communication. Registering a peer ID with the other party or parties in a relationship requires a specific protocol. This is the only protocol that must be supported by an implementation that targets layer 2A or 2B support. Registering, okay, so this is the only register is layer 2A and 2B, okay. Okay, because peer DIDs are supposed to be only resolvable only by peers resolution requests, and this method must not be honored if they do not come from peers. Okay. Encrypted connection request and inviter. Okay, so we do need this encrypted. We do need this encryption key. Okay, fine. Is libsodium cross platform? Message can be encrypted in Python on a MIT CPU. Decrypted in JavaScript using. Yeah, these people know what they're doing. Okay, first read the previous section. All right, so we know that we need to do it. Signing keys can be referred to. Okay. Usage, sign EDK, sign ED, PK2, curve, SK, public key, secret key, to a public key, okay. If you can avoid it using distinct keys for signing encryption. Yeah, if you can afford it using distinct keys for signing encryption is still highly recommended. Yeah, okay, so yeah, that would be great. But I think for our situation, we need to pull out the portion there. Okay, so what do we have here? Let's see this JSON web key. KID thumbprint. Okay, so that's the information that we have about it. KID and thumbprint. Is that all? What is this thing? Cache key pub K, cache pre K. Okay. Let's take a look at the API. JSON web key. Let's go look at, what's his name? Oh, yes, good. Um, preloaded web key. Password stuff, counter browser. Browser launch with DNS for you. Hey, Beaverton. No way. What happens here? Hello. Did you know? Oh, SSH. I can see you. Good flow. We try to look up. To look up your GitHub account, but got no match. This is great. Hmm. 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 So, so, I'm really glad I didn't go to bed. Um, this is interesting. This is very interesting. So what can we do with this information? Okay. Well, what can we do with this information? Can we do SSH over WebRTC? Can we do SSH over WebRTC? Here's what I'm thinking. If we can use the same key for our DIDs with GitHub, and we can communicate over WebRTC's channels with the SSH, with SSH doing the in, doing the basically doing a no, we don't need to do that. Okay. Yeah, because you could do a challenge response. Hmm. I wonder. Okay. What could we? How could we? There's something here. So if you host SSH server, so SSH server with the key pair. You host SSH server with the key pair. How do you do this? How do you exchange messages? How do you open communication? Well, somebody has some. Okay, so how do you open communication? You have to post somewhere to some channel. Some. That can be arbitrary. All right, give me the keys. Okay. Where did that go? Hmm. Where did that post go from? Oh, here. Okay. Provides the formulas. Signal, wait, it should be mentioned there. Press for. Okay, so Signal does this. Okay, well, if Signal's doing it, that's good. Uh, they use the X for ED. Does not carry a V coordinate. So we can map to two keys. They solve it by defining the Edwards point. Sum is zero, then negating the Edwards secret scalar to. It also comes out with more issues due to not having the other secret you try. But that's how scope I like to diagram on this blog post. See each other multiply Python ed2552 X25519. Okay, uses curve. Okay, key exchange. Converting leads to what? All right. To encrypt, take the y coordinate of the public key and convert it to a u coordinate, which we use as the X25519 public key ephemeral static to decrypt. Derive the secret scalar according to the. Simply use it as an X. Two pairs might end up with different V coordinates if they were to calculate them, but in X9, the shared secret is just the U coordinates and no one will notice. It remains open for future work is testing cross-protocol attacks. One that really concerns me is with partial forms, and Zeno will tell you if they decrypt actually also allows generating. They can be used to log into an SSH server. Okay. So let's see. Cartesian ED usage. This converts to a public key. Converts to an ED to a secret key and stores it in SK. Or says sort of save some time. CPU cycles, crypto sign open, crypto sign verify. Share. Alright, so converts into the secret key in what format though? Secret key in what format? When it is reused, when is it secure to reuse key material? Okay, Python. Okay, where's JSON Web Token? Okay, export private. Let's look at export private here. All right, all right. So pp print, p print. Oh, I guess I say it with an extra p. There's two p's on there. P print, p print. Oh, I'm adding an extra p. What do you know? P print JSON web key. What's up with that? It dumps it in a string. Okay, so CRV, KID, KTYX. Export private. No private key available. Oh, that's interesting. So that's why we can use it for signing. Um, hmm. SSH key. Okay, so if we can use this thing for encryption. Oh yeah, this is why this whole thing. So basically you can sign something for this key and you can create this DID, but that doesn't necessarily mean you own the private portion. It just means you know that the public portion, so you can sign something for it. So that's what they were talking about with that Genesis situation. So you really have to tie things to this signing aspect, which is what we're running into right here, is because we're right off the bat saying, well, I want to sign another link. How can we do this? Can we? I want to generate. I want to generate a key. What about this age project? I've seen this before, yeah. Integer small explicit keys. Okay. Ed25519. Alright. Document 2 is based on X. Okay, can we do, what is this? Community cryptography specification project. Okay. Just strange. Okay, hey, look at this. Look at this. Here it is. Boop. That's what we're looking for. Thank you. That is exactly what we wanted, I believe. So I think this is where we'll do the, let's see, this is where he does the add SSH ED recipients. Yep. So this is where he does the thing he talks about in his blog, where he enables doing something with SSH. SSH public key is 9. Here it is. Yep. There it is. Okay. Okay. So recipients test and SSH. So let's go check out the docs a little more here. HSSH. Okay, SSH keys. Also imports encrypting to decrypting with the respective private key. Encrypting to a GitHub user. This is what we're looking for here. Combining SSH keys to put in -r. You can easily encrypt a file to the SSH keys listed on a GitHub profile. Yeah, this is exactly what we're looking for. There's Alice. Okay. So, as a convenience feature, okay. 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 Ephemeral. Ephemeral. Our public key. So we're just gonna make, we make up a public key. And then we make up a public or shared secret. Or no, okay. Curve. We get the shared secret, we get our public key. And read rand. So we create this random buffer data. We get our public key. Shared secret. I think it's adding to ephemeral when it does this. And then tweak. Scalar size. Okay. Full th tweak. Okay, so takes this hash, puts it into this tweak, and then it says shared secret, tweak, shared secret, tweak, shared secret, now show SSH key, Marshall, recipient, SSH key, Marshall. So we take the recipient's public key, we marshal it into whatever this format is, and then we do our HKDF with SHA-256 once, and then stitch fingerprint, make, okay, we create a salt, poly, and then we do, okay, wrapped key, wrap, okay, new ED identity, base flat, wrap, private key, decrypt, unwrap, multi-unwrap.